Well, thank you very much, Jen. And let me just start by thanking, Sarah, Barbara, Jen, Sam, Jake, Tamara. You guys are doing a great job. Keep it up. And thanks for organizing this workshop. So I think the task I've been asked is to talk about the science of South Pole-Aitken Basin. And my apologies to those of you who have heard this talk multiple times. I think I've given it 20 times in the past 20 years. South Pole-Aitken Basin is an important place, and I hope to say why. Next, please. So, as you know, Barbara set me up really well. South Pole-Aitken Basin provides unique opportunities for lunar and solar system science, and that last part's important, solar system science as well. First of all, it's a unique location. It's the largest and oldest clearly recognizable lunar impact basin. As such, it completely resurfaced a huge part of the moon and therefore reset ages over an enormous area, melted a huge amount of material, and also by shock processes, reset ages. And so we can expect in this part of the moon to find evidence of that age. So SPA anchors the lunar impact chronology, as far as we know. And I would add that critical science is to determine the basin formation age and the SPA chronology. In other words, the ages of impact within SPA are also important. Next, please. So, compelling science questions. What was the heavy bombardment history of the moon, especially the early moon? We've heard a lot about a cataclysm. Was there a cataclysm? If so, what was the duration? When did it occur? And what caused it? And importantly, this is a key time in early solar system history. So what are the implications for early Earth and the terrestrial planets? Also, what are the implications for solar system dynamics? If there was an event that occurred well after accretion of the planets and the moon, then what caused that? We have a number of models, and perhaps it was simply the sweep up of accretion leftovers, but we need some data. Next, please. Additionally, we need to understand the very large impact basin formation process. How deep did South Pole-Aitken penetrate? Some of the hydrodynamic models and other impact modeling suggest that SPA should have excavated well into the upper mantle. Are those materials distributed around the rim? We certainly don't see them with remote sensing, but perhaps they're there in the regolith in breccias. We'd like to better understand crust and mantle and core structure processes that produce the heterogeneity that we see on the moon, the near side, far side dichotomy, and what was the role of South Pole-Aitken Basin? What's the thermal evolution of the early moon? How did the moon's crust and mantle react to this early impact, and what was the thermal state of the crust at that time? And finally, within SPA, there are basalts as probes, and we can use them as probes of the far side mantle. And again, getting at this question of heterogeneity of far side versus near side. Next, please. There are strong magnetic signals in parts of South Pole-Aitken Basin. What caused this? I won't spend time going through all the words here, but paleomagnetic studies of Apollo samples indicate an intense core dynamo at a time in the range 4.2 to 3.6 billion years. But we really don't have the data to get at the older ages and to understand this. So we have a number of questions about the dynamo. When was it initiated? How long did it last? And what caused it? Next, please. What's the thickness and character of the crust at the South Pole-Aitken Basin? We have some nice modeling now from Grail gravity, and it suggests that the crust is perhaps 10 to 20 kilometers thick. We think that's likely dominated by impact melt from the South Pole-Aitken Basin itself. The porosity is low, the density is high, but we really need to know the rock types to better constrain these models. Next, please. What rock types caused the iron-rich composition? Shown here is the Lunar Prospector Gamma Ray Spectrometer data, and it shows that the interior of the basin is elevated in iron. Now, there are Mare basalts here, but there's a lot of other materials that are also high in iron that are not Mare basalts. So is this reflection of the South Pole-Aitken Basin impact melt materials? Does this include mantle materials? Next, please. And the thorium content, also from Lunar Prospector, also shows that there's an enrichment in the interior of the basin. So this range, perhaps 2 to 4 or 5 parts per million. There's a couple of hot spots. The thorium content, as you can see here, of the interior of the basin does not extend all the way to the South Pole, but it is still elevated at South Polar regions. And so I would ask you to stay tuned to Cameron Moy's presentation later today, where he'll address this in more detail. Next. What does the mineralogy reflect? Some really nice work by Dan Moriarty, working with Carly Peters, has outlined a number of regions of South Pole-Aitken Basin. The interior, the high calcium pyroxene Spaca region, the low calcium pyroxene annulus, which really dominates a lot of the central peaks within South Pole-Aitken Basin and seems to be the dominant material that characterizes the crust, perhaps the lower crust or upper mantle in this region. And then beyond that, there's a heterogeneous annulus. It's a zone of mixing, and that's where the South Circumpolar region lies. And then there's the exterior, which is largely feldspathic highlands. What we don't see with remote sensing, at least at this scale, are concentrations of olivine or pyroxene-rich mantle rocks, that is, very plagioclase poor. Next, please. Barbara alluded to the South Pole-Aitken Basin chronology, and I'll emphasize this here with several slides. But contained within SPA are very large impact craters and some impact basins. If you click next, there's an animation here. It may not work, Ricky, but let's try it. There's South Pole-Aitken Basin hitting Apollo, Poincaré, and others. You can see, just to emphasize these very large impacts that occur, and they tend to deliver material to the interior of the basin as well as spread it around the rim. So the post-SPA chronology is going to be very important, and we hope to get melt rocks that allow us to test that. Next, please. So this huge volume of impact melt that's produced really gets concentrated by subsequent impacts to the interior of the basin. But again, many of these impacts are spreading SPA material toward the exterior, toward the rim. Next, please. So, big question. Did the inner solar system experience a cataclysm at about 3.9 to 4 billion years? This is the age that seems to be dominated within the Apollo samples. And we see here just a little schematic showing the age on X from 4.5 to 3.0 billion years. Was there a gradual decline or was there a spike? And South Pole-Aitken Basin and the other large impacts within it will give us another reading as to what this decline actually looked like. And again, this emphasizes it's a very key time. Earth's oldest crust is in this range. Earth's earliest oceans produced during this time, and the first life on Earth occurs just following this period. Next, please. Again, to emphasize, testing this paradigm, we really need a statistical approach. We need many isotopic ages, many impact melts, clasts and rocks that perhaps record these ages to identify not only the age of SPA, but the ages of post-SPA impacts. Next, I think this just will cycle through some additional text. So what does this histogram look like for the South Pole-Aitken chronology? You see in the dashed line what it might be, and it might be very different from Apollo, which again is dominated by the near side basins and perhaps primarily by Imbrium. Next. And we don't, there's a lot of talk about what the context that we need. We don't necessarily need to know which individual basins produced or craters produced a given impact melt. We just need to see the distribution and spread of ages. So the precise location, we can argue about it, but from a fundamental standpoint of getting these ages, it's not that critical. Next. Did the South Pole-Aitken Basin impact cause a global surge of magmatic activity? There's a number of good studies that have indicated the possibility that this basin was large enough to actually cause an episode of magmatism on the near side. So does the age of SPA coincide with the predominant ages of magmatism reflected by the samples? And you see this nice work from the results of Grail, Jeff Andrews, Hanna, showing this gravity gradient map. What caused that? And is that related to South Pole-Aitken? Next. There's also been recent work, nice paper by Francis Nimmo and others, discussing the possibility that there are other causes of the potential magmatism at about 4.35 billion years. And, a key question here is what's the role and the age of SPA impact? Is it perhaps an alternative or combined with the Laplace train transition that Francis and co-workers posited? Next. We can also look at some results from crater counting, and here's some early work by Harry Hiesinger and group, and it showed the possibility that South Pole-Aitken itself would be about 4.26 billion years. But I think subsequent work, and Harry would say that subsequent work was needed to sort of confirm this. So let's go ahead to the next slide. And in that work, they also dated some of the other large basins, Apollo, Oppenheimer, Planck, and Schrödinger, and found a range of ages that are closer to the 3.9 to 4 billion years. So perhaps SPA is not part of this cataclysm, but the other big impacts indicate that perhaps there was still a cataclysm. So lots to be unraveled from the samples. Next. And then some very clever work, Katie Joy and co-workers looking at a lunar meteorite whose bulk composition suggests an affinity to South Pole-Aitken Basin, or perhaps an origin there, and finding zircons that have an age of about 4.33. So again, we're in this 4.26 to 4.35 billion year range. Very interesting. We need samples to confirm this. Next. And then looking at a range of basin ages. Now, this is a more recent crater count using the buffered non-sparseness correction, and Orgay et al. Have dated a number of basins, and you see South Pole-Aitken there at 4.31, and then at arrows, some of the other basins in the region of the South Circumpolar area and South Pole-Aitken Basin, showing a range that stretches sort of uniformly or linearly down toward the more recent ages that we think we know from near-side basins. So again, this is a suggestion that the story is very interesting. Next. So what we really need is to constrain this part of the cratering curve at greater than 4.0 billion years. Next. So sample return via Artemis 3 and 4 will address key solar system science questions. This is sort of a summary slide. We'll be able to test this cataclysm hypothesis, not just from the age of South Pole-Aitken, but from the chronology of samples collected that were produced within this basin subsequent to it. Their significance for early solar system orbital dynamics, and their significance for the Earth-Moon system in terms of understanding the early impact chronology, implications for the evolution of early Earth, continental growth, atmospheric evolution, and the origin of life. Next, please. So don't just take my word for it. A number of very important documents have addressed the importance of South Pole-Aitken Basin science. The scientific context for exploration of the moon, of course, is a key document. And then here are 3 decadal surveys that pointed out the importance of South Pole-Aitken Basin sample return and the information we can collect from those samples for not only lunar science, but solar system science. Next, please. And that brings me to the end. Beautiful image showing sort of from the southern part of South Pole-Aitken Basin up toward the Apollo Basin. Beautiful view put together by Ernie Wright at Goddard. Thank you very much for this excellent work that you always do, and thank you all for your attention.